Hello people, it's been quite a while since I've posted a proper video, but now you're gonna get one. Here I am again at my workshop and we got some snow, and actually it's now a little bit too much for my Golf. I will not try to drive any further than that. I wish I had a Toyota Hilux like my mother does. It will go on this snow like no problems. Okay, I tried to start working, but I found a pretty nasty surprise. My lathe will not start, which is bad, of course. And I guess this is because last time I left here I forgot to switch off the electrics of the whole shop, so there has been power on the lathe for maybe 1 or 2 weeks in a row now, and at the moment it seems like the transformer is blown right here. And how I come to this conclusion is because I now have the electrics on. When I press the on button, nothing happens. And what it should do, it should start running the oil pump, which is behind this contactor. But when I press here, the oil pump runs just as it should, and also both spindle directions are working, and also this one. The transformer works so that 2 phases enter it on this side, and the outputs are on this side. This is, I think this is actually 0 and this is 110 volts. So this runs the secondary circuit and operates the contactors. But when I measure between 0, I mean the ground, and here it gives 0.9 volts, and it's the same on all of these. So I'm guessing this means that the transformer is blown. And of course all the phases get power and the lathe is running just as it should be, but the secondary circuit, the control circuit, is not working. Okay, I think came to my mind. Here I have my lathe electric box, my big lathe, and it has a 110 volt transformer, which at least last time was working, and I have no reason to doubt that it still is. So I'm gonna borrow it to test my smaller lathe. But take a look at this electric box. This is the way I ended up with the lathe, with the big lathe. Ain't this simple? It doesn't need to be any more complex than this. It has 2 contactors, 1 transformer, 1 overload protection relay and fuses. It will have wires coming to it from on and off switch, and then it's gonna have 2 motors on it, the main motor and the rapid feed motor, and of course the 3 phases in. So this is very simple, and to me simple is beautiful, and I hope the electric box on the other lathe will look a little bit like this in a while. So now I'm gonna take off this transformer, which you can see has 110 volts. So I'm gonna borrow it and see what happens. In today's standards, even this transformer I think would belong to the museum. The year is 78, made in CCCP, USSR. I think it's pretty nice. I cleaned it to some extent when I redid my lathe electric box. Okay, now let's put it in. And I don't recommend anyone in any circumstances doing this kind of electric work if you're not a professional. But when you do, be completely sure that you have no power on. I took off these both plugs, so there is absolutely no chance of pulling out the wrong one. So now this is completely powerless. Okay, let's do the switching. Okay, the transformer is now out, and I think it's so crude that it ain't even beautiful anymore. It's just crude. I think this is original from year 1967, and I found a problem with it. Take a look at this. It has one of the faces going in. There has been a contact problem, maybe rust or something, and it's been pretty hot and it has burned the wires off completely. So it was only getting one phase, and therefore it was not able to work. I think I'm gonna try to repair this one and put it back in. Okay, the new transformer is now in place. Here we go. So we have one bad transformer, and I took another look at this and see how badly the wire is burned. There is like 10 millimeters of wire missing, so it should be connected to that screw, but there is no wire in there. I guess I'm gonna take this home with me and try to fix it, but I'm not sure if I can do that. I think it might just still be fixable, repairable, but I wouldn't be surprised if I have to look for a new one. But since the lathe is now working again, I think I'm gonna leave it like that actually and keep working, and I'm gonna find a new transformer for this electric box. I guess it's a good idea because I will be, and I am overhauling the whole lathe anyways, and I think a good overhaul should also include electrics. I still have some old contactors and the overload protection relay in, but I cleaned them all and they should be good as new. Okay, I guess I'm gonna shut the door to the electric box and just start working. And I will try to fix this one, and if I can do it, I will put it back in, but I think at the same time I'm gonna overhaul the circuit board anyways. Okay. Okay, the day is almost over. It's been too busy to film, but I can now show you what I've done. First I did 4 of these. These hose plugs or something like that. They will be welded to something. And then I modified this brake caliper holder. I had to move these holes 5mm to this way, and that's what I did. My friend, whose these are, said that it doesn't matter if the old hole is still there. I think I would have welded them shut otherwise and drilled new holes, but I just went through with an end mill, so that was pretty easy. And on the other side I had to mill some more space for the caliper. This was a little bit tricky to set up in the mill. I drilled the holes, and this way it was easy. I could just put it in the vise from here. But this side was a little difficult. Let me show you how I did it. I used this small lathe chuck, and this fits here, and then I could machine it. And how I fastened this chuck to the table, I made a little knot in the middle, in the center hole, and it has a 12mm hole that of course goes through the chuck hole and attaches to the T-slots. And it's very, very handy to have a chuck like this. So I just fasten the bolt in there, and it stays on very, very rigidly. And when I want to turn it, I just open the nut and just turn it, and then retighten. It's very, very nice. And I have my last project going on here now. It's a pretty simple job of reducing the diameter of a brake disc by 5mm. I mean the diameter by 10mm. And this would be extremely easy if I had my big lathe, but as it happens, this is too big to be set up in my small lathe, so I'm gonna have to mill it. And I have already taken one pass, and I will take another. And since I haven't shown you any machining today, I guess I'm gonna show you this. Let me get you set up. Okay, here we go. I have around 400 RPM, and this is a 20mm 3-flute carbide end mill. It's used but pretty soft still. And now first thing to do is feeding down. Actually, I'm gonna use the screen of the camera as a mirror, so now I can see on the back side of the drum, I mean the disc. It's pretty handy actually. I just turn the screen so I can see what's going on. Okay, let's go. I have the rotary table locked. I'm gonna switch on and feed down, then release the lock and do the turn. It's gonna be tight. The end mill is quite not long enough. I have cut some relief at the corners because they cracked off. This is another one of those 2 euro used end mills. Okay, I guess I'm deep enough. Let's go. Okay, it's not liking it too much. I think that the end mill is rubbing. Let's try to lower the table a little bit. It's not biting, but I have a plan B. This end mill will not be too short. And it has just been reground, so it's very sharp. Okay, I guess this is enough of this. You have seen it all now. So, thank you for watching again, and again, I am hoping to be able to provide you some good videos in the future. Okay, see you again.